Noise. Okay, I'm live. Hello everyone. Welcome to another stream. Or another chill math stream. So yeah. I just want to check so everything works. I'm actually for the first time streaming on Twitch as well. So feel free to join the chat there if I mean if you're on YouTube there's no point in switching, but I'm yeah, just I feel like this format is more it fits better on Twitch, so that's why I had the idea to actually do it here or do it on Twitch. It's working. It seems like it is actually working. Granted, I have no idea how Twitch works. By the way, is it even working on YouTube? And oh, it's private. Oh, biscuits. Right. Wait, what? Is it private? Oh man, I effed I kind of messed up. Okay, it is live, but I messed up the output. So, okay, cool. Okay, let's change this. Hello to Moxa, Angelus, and HR Uncoded. Welcome. Let's change this, the title, and let's change the description, and let's change the thumbnail. Nice. Yeah, hopefully everyone has had a good day so far. Today I want to focus on doing some ODE stuff and some statistics afterwards. I did do statistics 2 days ago. So yeah, I wanna do first work on ODE before switching, because just to even it out, so I don't spend. I mean, I'm very good at spending too much time on one topic and then forgetting to switch topics. So probably that will happen today as well. Yeah. I'm also streaming on Restream as well, so it's, yeah, I don't really know what chat to look at. I guess the most relevant would be to look at the Restream chat, to be fair, because then I can look at YouTube and Twitch. So that makes sense. Okay, well, actually I wanna can I? Yeah, I want to add some rain sounds, just because I like having it in the background. I forgot to do that when setting this up. I'm not gonna lie, I spent around 90 minutes just setting this up. I don't know why it took so long. It shouldn't have taken this long. But it did. Okay, thunderstorm. Or wait, I have like 3 thunderstorm sounds. I'll take this one. Okay, sorry if that was super loud. I apologize sincerely. Yeah, and the mic is fine. Okay. Wait, I already have it. Wait, what? I already have it. Alright, I already have it, okay. I knew that. I definitely knew that. What does this mean? Embed chat. Display comments from all enabled channels at once. Wait, what? This is kind of cool. I should do more of these. I think you forgot the hashtags. Oh, I maybe did. I did actually. Thanks for mentioning that. To be fair, I was thinking maybe I should just end the streak. Like, is it really interesting? I don't know. I guess I'll have it for now, but it seems like maybe not the most relevant. Okay, things are going maybe good. I want to try this these is it media? No. Wait, bear with me a little bit. Image? No. And wait, I have two media. Yeah. Okay. By the way, is the sound like good? Is the rain sound like not overbearing? Hopefully it's not. I did rewatch yesterday's stream a little bit, and it seemed like everything was pretty alright. But just to make sure. Bruh, I can't find this. How was it that you linked stuff? Or maybe it doesn't exist on Linux. Okay, I think I'll just give up on this. Okay, whatever. Okay, we'll just start. Yeah. So I did scan all the pages that that are relevant when it comes to the OD course that I'm taking, and I'll basically just do the problems, read some of the stuff. Oh yes, my writing device. Okay. But how are you guys doing? Is everyone doing well? How is everyone? Things are working. Just put it there. Alright, cool. I think I'm on chapter. Oh man, you can see my thumb here when I scan the pictures. Literally, it took me maybe. Okay, it didn't take that long, but maybe 20 minutes of pure scanning, which feels a lot longer than 20 minutes. I have to say. Okay, so the chapter I'm on is on linear equation systems. I think I need to reread basically the whole chapter since I don't feel very confident. Oh, this is too far. Yeah, so linear systems with constant coefficients. Let's see here. Yeah, maybe I want to look at the problems. So yeah, there were some similar problems that I also wanted to do. Yes. So we're on 1.2. Oh, it was. Okay, these I want to do first. Oh, I forgot to flip this one. Right, so we start with linear equation systems. Can I do this? All right. So let's begin. Investigate consequences of theorem 1, 2 for linear equation systems. Okay, yeah. So theorems 1 and 2 are the global and local versions of the what is it called? Picard-Lindelöf. like the uniqueness of ODEs. Let's see. I want to investigate this a little bit. Okay, so normally you have, if you have an nth order ODE, let's see. Okay, yeah. So if you have an nth order ODE, it can be written as why did I include so many terms? Oh, okay. Yeah, maybe this should be n here. Alright, so you can write it as an equation system of first order ODEs by defining like this. So 1 is 0, so n is x, n minus 1. Okay. Okay, so these are the definitions which give rise to wait. Yes, okay, I did, okay. Yeah, so you can write any ordinary differential equation system like this, which can be rewritten as, I think it's called the ordinary form. So like this. Just solving for the highest order term. And like that. And this is equivalent to writing x1 prime, or x1 prime is equal to x prime, and never mind, x2, then x2 prime is equal to x3, and so on, up until we have xn prime is equal to this whole thing. Yeah. It still feels weird for me, but I guess it makes sense. All of this, we need to encode the higher order derivatives somehow, and we do this by having this, and then this thing just yeah. Or actually, here I should not have this. Rather, I should have n here. And yeah, that makes sense. I don't know what that was. Bruh. And this, we can make it, yeah, so we can write an equation system as a vector, which I'll just call x prime is equal to, what we'll say now is x or tx. Yes, that makes sense. And now we need to rewrite it as a matrix if it's linear. So okay, I think I did something totally wrong here. This is the general form of the linear one already. Yikes. What's that? Just a way of writing general forms of ODEs. I'm just trying to wrap my head around it, but it clearly doesn't make. Yeah, this is not a general form of an ODE, obviously. This is just a linear one. So I have written the general form of a linear one, and now we need to show that this is of the form this, and yeah, and we can do okay. So yes, okay. We have that. Yeah, so this is equal to x1 up to xn, and we have that. So this is a n by 1 vector, and so a times something. Okay, so let's do a matrix, and let's multiply it by x. Then we need to add something, and this needs to be equal to wait, can I highlight stuff? Okay. Let's move this down. Z prime of t? Yeah, that's what we're doing, Turk. I'm not sure what you're trying to say there, but yeah, that's yeah. I'm guessing the main diagonal is yeah, I think it's something like that, like this. So like it's offset 1, so this times this would be x2, and yeah, we need that. and then let's see. Let's see. Okay, so we have 1, 0, this, and this needs to be 3, and the last, okay, yeah, so the last one needs to be of constant. Can this just be ones? Or rather it would be the constants. Okay, blah. Blah 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 blah. Of course. That took too long. Let's move on. So yeah, so this would be up to an, and an minus 1, and an. And then the last one would just be 0 ... a negative a0, like that. So that I think that makes sense. Can you show me the question? I don't know English well in mathematical terms. Well, I guess that's a good point, and I'm also blocking the what I'm actually doing. Apologies. So basically. Yeah, maybe I should write it down on somewhere on the screen so it's obvious. Ooh, maybe I can have like a highlighter. But this equation, how can linear systems be written on this form? That's basically what I'm trying to figure out. Right, it's a good point. I should probably mention it more explicitly. But yeah, if you just perform, I was just trying to find explicitly the matrices, or the matrix A and the vector B, such that we can have this equality. And in general, your linear equation system, or ODE, can be written like this. Oh, where am I? Yeah, like this. Here. And we can rewrite this as an equation system. And this can be encoded in vectors. And by defining A to be this matrix, and B to be this one, we're pretty much done. Okay, I am convinced. Let's move on. Existence and uniqueness. Oh, is this lagging? It's not, okay. Yeah, hopefully that's understandable. Assume A be continuous in an interval denoted by T0 A, the compact interval around T0 with length A. The function f of t satisfies Lipschitz condition in the strip. This follows because if you put L to be the max. Yeah, I recognize this. So So the question is whether the linear is Lipschitz or not, and I guess I'll write it there. Lipschitz. And the question or the answer is yes. Since we can if you put L to be the max, when T is TZ is in this. It's in the unit ball. Oh. Yeah, that's okay. That I guess that makes sense. Yeah, because if you, it's kind of a weird thing, but it works, I guess. This can be written as this, and if we multiply by 1, we see that A is continuous. We see that these guys, this factor, is in the compact unit sphere in Rn, and or just the unit sphere, and we need to show that it's Lipschitz in the interval I t around t naught with distance a. So we live in a compact set, meaning that we can find the biggest value. So we can bound it. Yeah, exactly. We can bound it by L, and L is merely the sup of A of t. I'm pretty sure. Or it's the sup of the absolute value, or the norm of it. Well, here it says it's the norm of times z. Well, I don't really understand it, to be fair. It seems like a weird thing, because it's just a function of t, right? So why do we care about it being compact in the Rn set? We just care if it's compact in t, no? I don't know, man. Math stream? Yeah, this is a math stream. I've done 2 so far, but yeah, welcome Jeff. Welcome. What are you studying? Or I guess, yeah. I mean, I guess this stream is more like, yeah, just a chill stream rather than actually a study with me stream, which is different definitely for this channel. Man, the air here is so, it's not the best. Let me think. Okay, so AT is okay. So A of t, A is a function from R, or rather, we can just put in. No, we'll just say R. It's better that way. And it outputs a matrix, and by a matrix. So we only care, right? We only care if it's compact in R, right? So by theorem 2, it follows that the initial value. Yeah, I'll just leave it like here. I'll leave it here. I need some math genius, or you don't need a genius, but I need someone that's proficient in math to guide me. Let's see here. Here's my thumb. By theorem 2, it follows that the initial value problem blah 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 has a unique solution defined in da da da. Since okay, so it's. Since this is valid for any compact interval in I, we obtain a unique solution defined in all of I. So we can just extend it, which I guess is fine, but I mean, surely, like, it just, like, if we have that it's compact in an interval, in a compact interval, I was thinking about this the other day, actually. How you can define an open interval by closed intervals, and it's actually quite okay. Let's say we have yeah, let's say we have AB, and we have a compact, or rather like a closed interval. I guess AB could be infinite, it doesn't really matter, I don't think. But if this is closed, I think I can just do this. A little bar on top, meaning it's closed. There's a closed subinterval, or a subset of AB. I don't know if it's okay. We have that. yeah. So in this, what it's saying that if we can find a compact interval, like an arbitrary compact interval inside our or arbitrary closed interval inside AB, it automatically means that we can extend it to cover the entire set. Mm-hmm. By the way, hello, WNA, WNA. Hopefully things are good with you. I'm just trying to understand this book. Not gonna lie, this is one of the hardest books for me, at least. It's really difficult compared to the other courses I'm doing. This is by far the hardest one. Not even a competition. I'm gonna open the window. 1 second. Also, maybe I should start. I wanted to join the Discord as well. Yeah, feel free to join the Discord. Oh, another distraction. I also want to set a sub goal or a super chat goal. We'll do one super chat. Yes, okay. I wanted to do it, but I didn't know how I would celebrate. So you need a so in YouTube, if you want to set a super chat goal, you need to have like something you'll do at the end of when you reach the goal. And I'm wondering, what should that be? Any suggestions? Maybe I'll just do something boring. Like, I don't really know what to do. I have no idea. If you guys could come up with something, I'll do a poll, or how will I do this? Studying proofs right now? Nice. Are you doing like are you in high school or university? Wanna? It seems like if you're studying proofs, it seems like you're in university. Definitely not something I did during high school, at least. But you never know. And I'm not actually sure what I'll do here. I'll do, if I reach 1 super chat, I will. Okay, I know what I'll do. I'll do 50 or maybe 100 push-ups. 100 seems too much, maybe. I'll do 50 push-ups. I'll do 100 because I'm ballsy. An error occurred. Fantastic. Is it timer? Maybe I'll do 2 hours. Bruh, an error occurred. Can it work? It's lagging for some reason. Oh, fuck. Apparently, I should not place my laptop on this touch device. Has the goal gone through? Maybe not. Okay, it doesn't seem to be working. Sad. By the way, this is the live stream voice channel. If you can join, if you want to. If you want to study along with me, you can always join. Oh man, apparently it's not working. I don't know why. Anyway. I'm always conflicted when it's super dark outside if I should open the window or not, since a lot of bugs could come in. But I guess I need air as well. Okay. How's the Twitch stream going? It seems like there's like a 5-minute delay. Or maybe not, that's actually not true. Okay, okay, everything's good. Anyways, let's move on. Okay. Cool. I guess for this to be able to work, what I said here, we also need to make sure that if we have a closed interval, that the union of two closed intervals where a function is Lipschitz is also Lipschitz, which is it trivial? It sure is. It must be trivial. It must be trivial. But granted, I do remember me having a conversation with ChatGPT regarding something similar to this, and I came to the conclusion that it was not true, but I can't remember why. Okay, so I think it was Lipschitz. Let's search through my very, very private conversation with ChatGPT. So okay. Okay, let's do that together. You know, I seriously feel that looking through someone's ChatGPT history is as bad, or it's in the same level as looking through someone's web browser history. Do you guys agree? I think it's I think it's as ChatGPT is increased or like becoming better and better, maybe it will be like this. I don't know. But for me, when I did talk to this with my friends, and they're like asking for like their history, and I was like, damn, should I was feeling a bit nervous, but yeah, maybe that's just me. Hello, Baloo's red hair. Baloo's. Hopefully things are good. Yes, okay. Yeah, so that's not it. Oh, I think I did this during stream as well. Okay, I don't want to spend too much time on this. Maybe I'll just do a new one. Is it true that if a function is Lipschitz in an interval of A and B, then it is Lipschitz in the union? Or maybe not, actually. Maybe not. I'm thinking. Okay, let's pose this. If a function f Lipschitz on AB I'll just say interval A and B, then F Lipschitz on so this is my claim. We have like some wibbly wobbly. I would say it's Lipschitz here. Or even if we have like some like this. Differential A. Okay. Oh, it says not always. You can say Paul. Alright, Paul. Do you know this? Okay, a counterexample maybe. I'll just read. I don't know. If intervals are disjoint, no. Damn, son. I guess that makes sense. So if you have a function going 0, not defined there, and then here, not defined there. Yeah. It's not Lipschitz. Like on this interval is Lipschitz, and on this interval is Lipschitz, but in the union it's not. Well, shit then. Okay. By theorem 2, it follows that the initial value problem has unique solution in I T not A, since this is valid for any compact interval in I. We obtain a unique solution defined in all I. Maybe this is not this. Maybe I'm just overthinking it. Maybe I'll put the agenda down here so it doesn't block as much. Yes. should revisit the uniqueness theorems. I should. I really want to understand this like thoroughly. Oh, biscuits. Okay, well this page is flipped. Take screenshot. I'll just save as desktop. Click. Can I flip this one? You see my okay. Don't mind those pictures you just saw. Oh man, I love God. If you haven't seen if you haven't seen Superman, you're missing out. Guy Gardner is great in that movie. Okay, I wanna flip it. Rotate. No, not counterclockwise. There we go. I think, yeah, theorem 2 is what we used in the yeah. So here, bro, I'm still in the first page. How long has it been? It's been around 1 hour. Okay, it's gonna be a long stream. But like I said, I feel like this is one of the hardest courses I've studied. Anyways, okay. Since this is valid for any compact interval in I, yeah, so maybe this is like the extension. I feel like there was an extension theorem as well, because we're using this. We're showing that in a compact interval, this interval, we're showing that it's yeah, we show that it's Lipschitz here, and then the problem has a unique solution which is defined when t belongs to the interval. Yeah. I'll just ask ChatGPT to make this efficient. Okay, but how is it then possible that to say valid for any compact interval in I, we obtain a unique solution defined in all of I. Like it says in or am I stupid? Am I dumb? I don't think so. I think it makes sense. So the first check Lipschitz, and on any compact subinterval, the Lipschitz constant is the max, exactly, is finite. Uniqueness hold on every compact subinterval. Here is the result point, they write I is alpha beta. By local existence, you can solve uniquely on some compact neighborhood. Wait, I need to look at I remember there was a chapter on finding maximal solutions, meaning the biggest set of or I think it's the biggest interval where a unique solution lies, and maybe it's implicitly using that theorem. Yeah, here maximal solution. Okay, it's define an open and connected set and satisfies the Lipschitz condition in the neighborhood of every point there, but not necessarily with the same constant L at each point. Exactly. Consider again the initial value problem 1. By theorem 1, there is an interval 1 prime around T0 which has a unique solution. Follow the solution curve to the right a little bit to some point T1 near T0 plus alpha. Wait. Say here. Follow the solution curve to the right a little bit. Okay, here we can use theorem again with T1 x T1 as initial point. In this way we obtain a continuation of the solution curve to the right. supremum of tau, the solution curve can be continued to the interval. What the frick? Wait, does oh wow, does this mean an open interval? I've never seen this notation. I honestly thought this was a typo. But yeah, this is the open interval A1 to A2. What the frick? Our original solution near T0 can be extended to a function x of t. Also the differential equation there, but not in any larger interval. Such a solution is called maximal. What's up, Nas? Welcome. How are you doing? Okay, let f be an initial value problem, as in 1, be defined and continuous in omega, and satisfy Lipschitz condition in a neighborhood of every point there. This is what this is what they're saying here. So it's has a unique solution defined on I T0-A. Since this is valid for any compact interval in I, we obtain a unique solution defined in all I. Right? Yeah, exactly. So this is the yeah, exactly. So this argument is exactly what ChatGPT is saying as well. I'm not sure if I understand it though. Seems a bit weird, not gonna lie. Define A1, A2 as above, and let K denote a compact set of omega. Then for the maximal solution x of t of 1, the point tx of t is outside K if t is close enough to A1, A2. Thus the solution curve leaves every compact subset of omega. This means that when t comes close to A1 or A2 on all the form. Let's see. A1 is the infimum of tau. The solution curve can be continued to the interval indeed. Right, so these are the edge cases. Okay. Continues in omega and satisfy Lipschitz condition in the neighborhood of every point there. Define A1, A2 as above, and let K denote a compact subset of omega. Right, so we have different solution curves. So can't A1, A2 be infinity at some time? Or I guess we don't care. 0. Sure leaves every compact. Oh, I see. Example 5. All right, so let's see here. I see. Okay, actually I should go through this example. Yeah, I'll do that. I will. So this is an example of a situation. Seems like situation 1, no? In example, we have a case of 1. Yeah, exactly. Since the function doesn't blow up in the interval. Studerar du bara matematik? At the moment I am, Oscar. Indeed. But I will do some physics next semester. No, it's this semester even. I think. Wait, let me look at my study plan. But I think, yeah, it's this semester I'll do some physics. And then probably I'll end with physics after that and just do pure maths. I just want to remind myself as well. Yeah, I'll do some physics this, exactly. And then this semester is only maths, yeah. Alrighty. You know, I was thinking I'm gonna have topology next semester. And it would be nice doing like topology Tuesday streams. That just rolls out the tongue really smoothly. Topology Tuesdays. Or maybe I could have Fourier Fridays where I do Fourier analysis, because I do study that right now. Rather, it's linear analysis, but Fourier is a subset of that, if you will. At Lund University, yeah, it is. Titta bara... Oh man, this is Danish. Du kan bara utväxling till kanske. I can't read this. Utväxling. What do you mean? What is bottom? Or lave? I can't decipher this Danish. You have to help me out. You know, honestly, I thought reading Danish would be simpler, but it's not. Or I guess it's a little bit easier, but I still can't understand it. But yeah, are you going in? Are you studying at Lund University? Yeah. Gör det. Okay. Yeah, sure. But I don't think I will. I'll study. I want to study my master's abroad, not really in Denmark. But granted, I could do. I could do that, but I like how you deciphered lave using more Danish. Är i Århus på matematik? Okay, I don't know where that is, but fantastic. Maybe I've been here. No, I haven't. Oh, you know what? I think I was at a conference in Germany a couple days, or during late August, and I think a couple of the people there were from Aarhus. And it makes sense since it was a math conference and you're doing math there. It certainly makes sense. Alright, well maybe you can help me out. What year are you in? Second largest city in Denmark? I didn't know that. I only know Copenhagen. If you're in second year or above, okay, I'm not gonna, yeah. But maybe you could help me out, honestly. I'm just doing some ODE stuff. My goal is to accumulate as many math students in these streams, so I can just I can easily get feedback and stuff. That would be awesome. I've only just begun, so perhaps you can help me. Okay. Well, yeah, I'm willing to help. What are you working on right now? Is it one variable? I'm guessing one variable, and you're doing a bit of vector geometry stuff, algebra. At least that's how it is in the Lund program. You have you have vector geometry, algebra, and one variable, and then you move on to linear algebra, server variable calculus, and some more higher analysis stuff. And that's basically the entire first year. Alright, I need to go to the bathroom real quick. I'll be right back. Uno momento. I think I'll do a couple. Oh, it's actually not that late, you know. I'll do at least 2 hours more. Yeah. And can I set up the goal though? I can't. All right. Alright, I am back. Cool. Elementary algebra, mathematical analysis, and probability plus statistics. Oh, it's kind of cool that you're doing that the first year. I mean, statistics is something I'm doing right now, like in my second year. Hello, Jake. I'm in algebra 2. Cool. I'm not really sure what that is for course, but sadly we're not doing algebra today. Actually, yeah. I'm not even taking any algebra courses, so which is fairly sad. I do love me some algebra. But yeah. Let's move on. So the problem, yes, I want to do an example before moving on. I want to look at this example 5. Yeah. Do you still live at home? I am currently living at home, but I think I'm gonna move out in next month. I've been looking for apartments, and there are 2 apartments that are open at the nation I'm at, so hopefully something will happen there. Your video, my first year of studying pure mathematics, only has sound in the left ear of the headphones. Does it? Oh, that's not good. I guess I didn't really view this audio. Okay, well that's news to me. Hello, cookies. Welcome. You know, okay. I feel like I should just stick to streams, eh? or I guess I did. Yeah. I don't know if my shorts were like that. Honestly, I don't really look at the audio stuff. Anywho, example 5. So we have a value problem. So generally, this is a separable ODE, and yeah. So you could just solve this like explicitly, but if you want to use theorem 1, we need to make sure there's a unique solution in a neighborhood. Oh yeah, so we know it's Lipschitz automatically. Okay, let's just write this down like this, and we need to check that. So this is our function. And so I guess the conditions of theorem 1 was that we need to make sure that it's continuous and Lipschitz in a neighborhood, and I think that's it. clicked one. Title of this says it all. I'm sorry. No, but we're specifically doing, or I'm specifically doing ODE. Granted, in the agenda, I should probably mention what I am at, like what. Yeah, how will I do this? Okay. Yeah, so the stream crashed. Okay, I think I'm back again. The stream kind of crashed, or my OBS crashed. Okay, cool. Yeah, let's add a star here. That's where I'm currently at. Or maybe I'll do an arrow, actually. I think it's better. Dream College. Well, I do want to go into Cambridge. I want to do the mathematical, or part 3 of the mathematical trippers, or whatever it's called. So I guess I want to do that. Yeah. I guess that's my dream college. Okay, continuous in a neighborhood. Satisfy there's an open interval around T notes. I just find this so confusing. Are you top of your level, would you say? What do you mean by that? Like best in class, or and if that's what you're meaning, I would definitely not consider myself the best or whatever. There are certainly people that are they have a lot more experience in maths. I'm probably one of the newer people, like when it comes to mathematics. I probably have the least amount of experience. Wait, where is the example? I lost it. Yes, so it's okay. So we need to make sure that this is Lipschitz in X, and it is clearly Lipschitz in any compact interval. Yeah. Since it's C1. Yabba-dabba-doo. So there is for sure a solution, a unique solution in the neighborhood of T0. Yes. A sub of R of X2. Man, why is this being it's a bit confusing? So we have a neighbor around T0, and we define a region. We consider the biggest x in the region, or x squared. I guess this makes sense. The solution is therefore defined. But why is this true? Why is the solution defined when f lower t is less than or equal to this? Okay, so it's a neighborhood of T0. But let's look at this again. Honestly, maybe I'll move on to statistics even now. I haven't done a lot regarding ODE, but time has nonetheless moved on. moved. Okay, so it's continues in the neighborhood. Okay. So the initial condition is x naught is 1. We need to have it that it's continuous. So is f of, and this is a function of t as well, so is f of t of x equal x f t squared continuous and Lipschitz in some neighborhood around 0, 1. So that's the question. I just need to explicitly write this down. Cool. So how the book is arguing is a neighborhood around, we can write this as the region of points tx, where t is less than alpha naught and x1. So the idea is what values are alpha, naught, and beta. Since we want to evaluate where the ODE has a unique solution, and we can consider it okay, so we can consider, yes, so solution is defined so when this is true, the minimum of a naught, or alpha naught rather, and I really don't understand this reasoning. Let's use our most powerful tool, ChatGPT. Why is the solution defined when absolute value of t is less than or equal to the minimum of a naught b one plus b squared? Okay, after this, or actually I wanna solve this and then I'll move on to something else, to statistics. This goes right to the heart of Picard-Lindelöf. They consider a rectangle Want to see your statistics problems? Yeah, I'll move on to that in a bit. This is bounding. Why does it need to be bounded? F is bounded in the region. Consider a rectangle. Or not. Yes, this is our rectangle. We just need to make sure inside this box we have that it's continuous in Lipschitz. On some interval t, yes, blah 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 blah. So we have that. This is less than. So B is the maximum spread the solution can have in that box. How long can the solution stay inside the box? Now, why does the length of existence interval depend on? Constraint 1. The box only extends in t direction by alpha, so no solution can be guaranteed beyond. The solution starts at x naught 1, can move up or down, since the derivative satisfies Since the derivative satisfies, the solution cannot change faster than the slope b. This is making me more confused. What the heck? Yes. Oh, we have x. Oh, wait. So, I also don't understand that, actually. If you look at the picture, how is it true that that the slope is bounded by the biggest value inside the interval? Oh, is this... Oh, okay, I'm dumb. Okay, I'm so dumb. Okay. Yeah, to leave the box vertically, it would have to move at least beta away from the initial value. The solution leaves the box vertically. Is it not valid if it leaves the box vertically? Why not? Have to move at least beta away from the initial value. Right, so alpha would be that one, and then we would have right, so if you would move, you would pick I don't seem to understand this. This is... Solution cannot escape vertically. What does that even mean, honestly? So this is the largest value of x square inside the interval. So if I don't know, man. I don't know what this means. It's actually good that I'm going actually trying to understand this, since this is not even what I'm trying to understand. I'm much later on in the book, and it seems like I haven't really gone through the the beginning of the book. Hello MD, welcome. Please insert it into me. What does that even mean? Let's slow it down and back. We draw a circle box around the initial condition, indeed. So it in the tx plane, the horizontal boundaries are at t plus minus blah. This box is where we want to keep the solution. Let's draw a picture. Let's draw a picture. So if we have a box, and we have the solution going here, like we can just draw it like this. As I understand it, if we have a box that is maybe too big, like this, it can escape from above, I guess, but I guess the solution is still within this this box. And this is our initial conditions here, 0, 1. So we don't want to pick t to be too big, since it will just escape. Maybe if you cross the top or bottom boundary, we say it has escaped vertically. Yeah. Yeah, that makes sense. Escaping vertically means that x of t minus 1 is equal to beta. Escaping horizontally means, so escape vertically before a certain time means given the maximum slope, solution cannot climb up or down fast enough to achieve. Yeah. why does this? Is it because we cannot pick? Like, it's not Lipschitz if we don't do it. If it's scaled vertically. Why is the function escaping vertically an issue? Like, if we live in this area, we have that it's bounded by B, and we want to make sure that this is our, like, we want to make sure that we find a region such that this is our Lipschitz constant. So if we just restrict it so that it doesn't escape vertically, we can ensure this. I think that's the logic. Yeah, I think yeah, that's the logic. I don't need to read it. And yeah, we want to make sure that this is less than. Okay, we know that the. Yeah. And right. And this is the same as saying this. It's the rate of change, so it's at least this, and blah 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 blah. Or we can say that this is our beta. And this is our B. Equal to, or is equal to T. Yes. Or maybe wait. I guess I'm not quite sure with that actually, but at least this is true. So anyways, we can blah, 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 blah. So it doesn't escape vertically. Then we know the Lipschitz constant is the biggest value of this, which is 1/4, and blah blah blah. Thus beta is this, alpha is this. We conclude the solution is defined in the interval where it satisfies. Wait. Should say in the interval T where it satisfies. Right, so that's the range. So it's 1/4. Yeah. That makes. Okay, yeah. So we have. Why is there a 4 there? Conclude that the solution is defined in the interval where it satisfies so the upper bound is 4 of T. Wait. Okay. Yeah. So this is like actually doing it explicitly, which did confuse me a lot. Okay, but I think I understand this example now. Granted, this last thing, I'm not sure if I 100% understand. So it's beta. Beta is 1 and alpha is 1/4. So right, and checking the largest value is by doing the derivative, right? And checking the maximum points, which is rather standard. Yeah, okay. Let's do some statistics now. I don't know, for some reason this text is just super difficult for me to understand. I'm not 100% sure, like, I don't know what it is. There's something with it. There is something that is just difficult with it. Alright. Maybe it's just the definitions, like, it's not really that... Granted, I'm doing another course on linear analysis, and I guess they seem very similar, but for some reason it's easier to understand the linear analysis course, which is on Fourier analysis. But anywho, okay, what did I want to do with statistics? Okay, yeah, so I missed a lecture yesterday because I had like some driving class that I need to attend, so I want to cover what I missed. Sounds like a good idea. Oh yeah, also there's a lab I need to attend. Okay, I think I need to focus on statistics a lot in the coming days. Yeah, there is a lab. Okay. Yeah, I want to send... Okay, let me do this right now, so I have it done. So apparently you need to work in a group for the lab, and I'll just ask my friend if he's available. I haven't asked anyone. So there's... let's see here. click. Oh. Okay, there you go. No, wait. Here it is. So I guess we're on week 2, and I had lecture 5 on continuous random variables. Indeed. Okay. So, and this is chapter 2. So let's do chapter 2. Yeah. Continuous random variables. Do I have upcoming exams? I have a couple, I guess, but that's in the future, like maybe a month ahead, I think, at least. Yeah, so I'm currently in week 2, and I think, yeah, they're week 7. Wait, what is it? Okay, yeah. No. I think week 4, there's the midterm, and then onwards is, yeah. So I guess in maybe 2-3 weeks. So not really a month. Okay, so by the way, what was chapter 1? So we had uniform probability of finite spaces, conditional probability and independence, continuity of P. Okay, let's just read section 4 then. I haven't read the entire chapter 1. I already have 3 exams this week. Alright, well, good luck with that, Leah. Wish you the best. Okay, let's do this. We'll have to come down to being able to compute sizes. This is all that is. Count the number of elements in the various sets. The science of counting is called combinatorics. The science of counting. That's very broad. Very sophisticated. In the remainder of the session, we consider a few. Suppose we flip 3 fair coins and roll 2 fair 6-sided dice. I'll head up to study by. Alright, bye, Leah. So we have k finite sets, and we want to count the number of sequences of length k where the ith element comes from SI, i.e. the count of the number of elements. Okay, that's kind of, I don't know, this was difficult to understand, but I guess it makes sense. Like, suppose we have k finite sets S1 to Sk. We want to count the number of sequences of length k where the ith element comes from Si. Okay, I guess that's fair. This looks like my kind of stuff. Nice. I've never okay, well, okay. I accept this. I accept my fate. This is okay. Example 1 point. Suppose we what is the probability that the sum of the numbers showing is equal to 10? The total number of possible outcomes is equal to 6 times 6. Of these outcomes, there are 3 that sum to 10. Is the probability that the sum is equal to 10 is okay. Okay, well, this is consider again 3 coins. So the first coin comes up. Well, of course, should be. We can see this more formally by saying that probability first coin heads. But suppose now that the informant tells us that exactly 2 of the 3 coins came up heads. Now what is the probability that the first coin was heads? The point is that the informant has changed our available information, changed our level of ignorance. It follows that our corresponding probability should also change. If we know that exactly 2 of the coins were heads, then we know that the outcome is one of if we know that exactly 2 of the 3 coins are heads, then the probability that the first coin is head is 2/3. Yeah, more precise, we have computed a conditional property probability, that is, we have determined that conditional on knowing the exact 2 heads came out heads. Conditional on knowing the probability of first coin heads, 2 coins heads is that the first coin is heads stands for conditional on, given that. Okay. Are you just reading stuff or also solving problems? Well, I'm certainly solving problems as well, but I need to read the theory first. Yeah, so I guess that's the structure, like reading theory and then solving problems afterwards. I don't know, maybe I'll take a little bit of a break because my brain is completely, or not completely fried, but almost. So maybe I'll take like a 10-minute break and then maybe I'll do 30 minutes left, because I do want to get some statistics done. Probability that the first coin is head, given that 2 of the coins are already head. Or no, given that 2 coins are head. But I guess we need to have like our universe, like what is it called? Like our S, given S is defined. In general, given 2 events A and B with probability that B is positive. Wait, what? The conditional probability of A given B. Oh, it's strictly positive, so it can't be 0. Okay. Stands for the fraction of time that A occurs once we know that B occurs. Okay, let's write that down. Let's go to our statistics whiteboard. Maybe I'll do a new whiteboard because this is already full. Stats. No. Yeah, so we have conditional. So if S is our sample space, A, B events, fraction B, probability of B of the time, also both A and B will occur a fraction of the ratio thus gives the proportion of time when B occurs. But A also occurs, yeah, okay. We ignore all the times that B does not occur and consider only those times that B does occur. Then the ratio equals the fraction of the time that A will also occur, with a conditional probability of A given B. Yeah, I guess that makes sense. We want to know the probability that A has happened given the probability that B has happened. What B is the event that exactly 2 coins were heads. So all the events that, yeah, exactly. Let's see. Two first coin tails. Does it make sense? Conditional probability? I mean, I guess it makes sense, roughly. I'm thinking the purpose. What is the purpose? Like, okay, so here's like an example. So first, coin tails. Is equal to 1/3. So this set, I guess it's just 3 elements, or no, it should be should be 4, right? No, it should be, wait, should be 6. Tails, head tails, tails, no, am I, okay, let's just do this explicitly, since I cannot think today. Yeah, it should only be 4. Yeah, so it's just the inverse of this. Okay. Okay, with that being said, I am going to take a little bit of a break because I think I need it. But anyways, yeah, I'll see you guys in like a couple of minutes, I guess. I haven't looked at the Twitch chat though. We have one guy that joined. Nice. And then I got a an ad or someone promoting their shit. But I don't think I can see the chat, like the Twitch chat. Oh, I can. Nice. I didn't see it, but now I see it. I had studied it in my high school, really loved it. Nice. Yeah, this is not something that wasn't mentioned, or I don't think so at least. Conditional probability. But yeah, anyways, I'll be back in like a couple, maybe 10 minutes or something. Alright, I am back. Let's just continue. I did also have some like a snack break because I felt really hungry. I was like shaking, which usually never happens, but whatever. I got some food. Alright. Let's see, this definition. This allows the computer to join probability of A and B when we are given the probability of A and the conditional probability of B given A. Oh, girls have long hair, twin boys have long hair. If students are uniformly at random from the class, what is the probability that the chosen student will have long hair? Oh, okay, well, okay, let A1 be the set of girls, A2 to be the set of boys, then there's a partition of the class. We further let B be the set of all students with long hair. Interesting probability of B. Oh. Oh, I see. Okay. So this is probability. And normally you would write it as theorem 1.3. Ah, yes, right. So you use the additive property. Right. Okay. Suppose I need to advance each of positive probability in some applications. We are given the values PA, PB, and PB given A. You want to compute PA given B. The following result is such a simple issue. Wait, let me see. So what this is right, so the probability of so we have long hair given girls, maybe it's A1 girls. Yeah. So this would be that's was it. So yeah, so it would be a half, right? Wait, maybe no. No, obviously not. It would be 30%. And by definition, it's probability of is it long hair and girls divided by what is that? Some noise outside. Alright, so that would be 1, right? Or long hair is how do you even calculate that? So you do the additive property since these are disjoint, or we don't. No, these are not disjoint. I think I hear fireworks outside. What the heck? Prep for G, advanced in my higher school, secondary school. That time I read this chapter. Oh, cool. Yeah, GEE advanced is, as I've heard, one of the most difficult entrance exams you could do. So I guess that's fair enough. Or rather, it's actually the intersection, not the union. Yeah. So what is the probability of... Okay, well, this is... Is this obvious or not? So 60% of girls and 30% have long hair. What is the probability you have a long hair and a girl? I mean, I guess... Wouldn't that be 30%? No examples or anything? I mean, we do have examples. I think kind of a lot of examples, I would say. So... Oh, wait. I don't really understand this. Am I dumb? Wouldn't it be 1/3, 1/6? Wouldn't it just be half? Here it says that this probability is 30%. Like, if the probability of someone having long hair and being a girl, we know that 30% of girls have long hair. Oh, 30% of girls. Oh, sorry. So... what would that be? Yeah, so it's 30% of yeah, 30% of 60, and we will have 0.6. Okay, yeah. That makes sense. Okay, base theorem. Let A and B be two events, each of the positive probability, then we have that. Okay. Okay, that example makes I guess sense. I don't know why why that took so long for me to understand. I guess I don't even know. Okay, well, here we have some interesting relation, I guess. Do we just apply the definition? I mean, I assume so. We have probability of A intersects in B divided by probability of B is equal to A B probability of A intersection B probability of A, and these cancel and we're done. Occur with two-stage system. response for such system can be thought of as occurring in two steps or stages. Typically, we are given the probabilities for the first stage and the conditional probabilities for the second. The multiplication formula is then used to calculate joint probabilities for what happens at both stages. The law of total probability is used to compute the probabilities for what happens at the second stage. Okay, let's do that then. Example 1.52. Suppose earn 1. Suppose one of the terms is selected with probability 1/2 each, and the other one, and then one of the balls within each that earn is picked uniformly at random. What is the probability that earn 2 is selected at the first stage, and a blue ball is selected at the second stage? The multiplication formula provides the correct way to compute the probability. Suppose we instead want to compute the probability that a ball is obtained using the law of total probability. So that a blue ball is obtained. Okay. I see, yeah. Mention that the ball pick is blue. Then using Bayes' theorem, the conditional probability that we selected R2 is given by Sample stage is second stage has got two stages. A tree depicting the two-stage produced. Oh. Alright. This is the same as an unconditional probability. It seems that knowing that the coin was tails had no effect whatsoever on the probability that the coin came up 5. Knowing that I guess that makes sense. We say that a coin and die are independent in this example to indicate that the curse of one does not have any influence on the probability of the other. A, B, independent. If so the probability of die is 5 is the same as the probability of so we have that A is the same as probability of A conditional B, and this is the same as probability of A B divided by probability of B. Yeah, so I guess the definition makes sense of that. Yeah, I guess that makes sense. In example 1.4, if A is the event that was not is good, then A be independent in this case. For multiple events, the definition of independence is somewhat more involved. Well, I guess that's obvious, or a natural extension. According to the definition, 3 events are independent if for all, and if it is not sufficient to check just some of the conditions to verify independence. For example, suppose of the three equations hold, but the equation does not hold. Ew. Yeah, okay. Pairwise independent. Oh, I see. We have AIJ. Okay. Right. So you need all like all combinations of intersections between the events. So the intersection of this would be 1, 2, 3, 4, and that is equal to 1. But if we multiply them, P of 1, 2 times P of 1, 3. This is yes, this would be 1/4 times 1/4. Would this be like this? Yeah, this is not equal to 1. So, but otherwise, if we have probability of B intersection C. Oh wait, that was, yeah, no. So it's 1/4 here. Yeah. So AB intersection is 1/4. P of A is isn't it just one? No, wait. This feels wrong. This feels wrong. Wait, probability of A intersection B. This is equal to probability of just 1, which we define to be 1/4. But probability of A. I don't, wait, what? Oh, yes, of course. So it's, you add them first, yes. Yeah, so it's 1/2 times 1/2, okay. I thought so. Yes, so this would be 1/2 to the 3. Okay, well, I think I'm just gonna call it a night there. I have some exercises that I should do, and I want to do some continuity in chapter 2 as well. Sadly, I didn't really have the time to do that today, but yeah, I guess I'm fairly satisfied with how it went during the stream. Maybe a little bit slower than I would have liked it to be, but. I think the stream was around 4 hours long, with like a crash at like the midway point. Honestly, I think the thumbnail is absolutely golden. Anyways, yeah, I'll see you guys tomorrow. Okay, tomorrow I'll do a long stream. I won't be going to my dad's to do some driving, since yeah, I want to focus on studying. So I'll see you guys tomorrow. Hopefully at the morning, like in the morning, where I'll do maybe a study with me stream, and then in the evening like a chill math stream. I think that's what I'll do. So yeah, I'll see you guys then. Alright, peace.